Hey guys, Mr. Mises here, and in this video I'm going to be talking about linear regression t-test. So we'll go straight into this. This is the problem that I had some students working on today in my class. So if you take a look and read the context there, we're talking about looking at if there's an association, if there's evidence of an association between anxiety level and math test score. That's what we're really looking at. So if you notice here, I have some computer output, and the computer output is going to be necessary for us to do this linear regression t-test and our confidence interval. We really can't do it without it, so we're going to need some technology in order to do some regression on some regression inference. So we're going to go and do that through every step. I'll try to explain why we're doing what we're doing, but the most part is that you understand every step of the way, okay? So first, what are we trying to determine? We're trying to determine if there's an association between anxiety level and math, and really if there's evidence of that association. Not how strong it is, just whether or not there's evidence of it. So what I'm going to do is for my null and alternative hypothesis, and I have it down here on the bottom, as well as the conditions. I was in the middle of doing the conditions. For some reason, my last video kind of cut off. So my null hypothesis is that there is no association between math test score and anxiety level. The way that I write that is using a beta, so a Greek letter beta. Beta 1 is equal to 0. Beta 1 stands for the population parameter slope, because if you think about it, if there's no slope, there wouldn't be an association. If there is a slope, then there is some sort of association. So our alternative hypothesis is that beta 1 is not equal to 0. Remember that our statistic here is B1, which is the slope of our regression line. This beta 1 is kind of like the population slope. If I had all students all over the place and I drew their regression, I would have beta 1 as my slope. So I'm looking to see if beta 1 is not equal to 0. That would tell me if there's an association. Here are my conditions. The first condition is that the scatter plot has to be straight enough, meaning there's no curve in the data. So I would just point that out by looking at the scatter plot. Independence assumption is that each student is independent of each other student. So the test scores, there's no reason to assume that test scores are not independent. The scatter plot needs to be consistently spread out, meaning it does not fan. And what I mean by that is it doesn't like start down here and go fan out this way, or start here and then fan in like that. So the points don't kind of go like that, right? They got to be consistently through some sort of linear relationship. Lastly, we have the nearly normal condition, and the nearly normal condition is based on the histogram of the residuals. Okay, so we're looking at actually the residual histogram, not a histogram of the students or the anxiety level or each individual when we're looking at them together. So I would say here that the nearly normal condition is that the plot of residuals is unimodal and symmetric. All right? And I can just refer to the one that I have right here. That's why we have the plot of the residuals right here. Okay? So it's fairly unimodal symmetric. And then so we're going to state our test. We're going to say we're going to use a linear regression t-test. And the degrees of freedom are going to be n minus 2. All right? Because I have two variables, and so I have n, which is 24 minus 2, which is 22 degrees of freedom. All right, plus it'll tell me. So if we look at our output, this is where we're going to, and our mechanics. So remember, we have our next part is going to be our mechanics. Our mechanics are really going to come from our output. So all this stuff is our mechanics, and we're just going to label and locate the things that we need. Right here we could see the degrees of freedom. All right, so we're gonna state our degrees of freedom, which is 22. We're gonna create our linear model. All right, so we're gonna write our linear model. in our mechanics. So our linear model, remember, we focus right here. So we have anxiety level hat is 91 point, oops, not anxiety, sorry. Math test hat is equal to 91.6583 minus 4.48624 times anxiety level. Now, if you're wondering, Mr. Myasis, where did you get those numbers? Again, I circled them right here. This one right here is B1. I'm sorry, B sub 0. And this one right here is B1. Okay? B sub 0, B1, our slope and our y-intercept. So I want to write my linear model down. So I have that. And then I also want to write our p-value. All right, what is our p-value? Our p-value, can we look? Okay, what you're going to do is to find our p-value, you're going to go to the variable that says anxiety level, so whatever our non-constant variable is, where our slope was, and we're going to go all the way down. There is our t-value, negative 2.89, and here is our p-value. This is our p-value right here, okay, because it's right under probability. So our p-value is going to be 0.0084. Okay, so from there we can write our conclusion. So, since the p-value is lower than 0.05, there is evidence of an association between math test score and anxiety level. Okay? All right, so let's say we want to find the 95% confidence interval. Okay, so let's say we're trying to find a confidence interval. Here's the formula for our confidence interval. So the formula for our confidence interval is going to be B1, which is our slope, right? Plus or minus T star, with our degrees of freedom, times the standard error, of B1. And again, the standard error of B1 you're going to need from our output, okay? So let's go up to our output and see what we got for each of these. So B1 is going to be negative 4.48624 plus or minus. Now we want T star for 22 degrees of freedom. So we're going to go to our table, our T table. And I don't have a T table in front of me right now. Well, actually, I do. Give me 1 second. All right, here we go. We got our T table. So let's go to 95% confidence with 22 degrees of freedom, and that is going to give me a value of 2 points right there. What? Okay, so you're probably going, what are you doing? 95% confidence with 22 degrees of freedom is 2.074. All right, so 2.074. And my standard error of my beta, or my, I'm sorry, not beta, of my standard error of my slope, we can find. It's given in our data, our computer output. So out right here it is, guys. I think you've already found it. I know you guys are smart enough to find it, right? Standard error. Here's anxiety level, right? This all represents B1. So our standard error is 1.551. So that's what I'm going to use for my standard error. So I'm going to go down here, 1.551 that I got from my output. And I'm going to go ahead and calculate. I know you guys are going, what are you doing? I'm going to go ahead and do the math there. And I get negative 7.70 and negative 1.27. So I want to interpret this. We are 95% confident that for every increase in additional unit of anxiety level, we would expect an average decrease of math test score between 1.27 and 7.70 points. All right? So we're basically interpreting the slope, right? Because that's what these represent. They represent slope, but between two slopes. We're talking about a confidence interval between two slopes. So we're 95% confident that for every increase in additional unit of anxiety level, we would expect an average decrease, because they're both negative, of the math test score between 1.27 and 7.70 points. So that's how we interpret it. So there you go, guys. This is inference for regression. The good news is the mechanics for that are all on all from a computer output. So it's really important that you learn how to read that computer output. All right, guys, we'll talk to you soon.